Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about search ranking. This episode is based on a tech blog titled Improving Search Ranking for Maps, written by the data science team at Airbnb. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Airbnb is one of the world's largest online marketplaces for short-term lodging. It connects millions of guests with hosts across more than 220 countries. Search is at the core of the platform. It helps guests to find listings that best match their preferences, budgets, and locations. Traditionally, search results are displayed as a ranked list. But Airbnb also allows users to browse listings directly on a map. This map-based search gives guests a valuable spatial perspective. They can see where each property is located relatively to landmarks or neighborhoods, which is often a key factor in decision-making. However, this map-based search also introduces new challenges. Unlike a list, where items are ranked top to bottom, map results are spread out geographically. When hundreds of listings appear on the screen, it becomes hard for users to know which pins deserve their attention. Instead of helping, surfacing too many listings can overwhelm and even discourage guests from making a decision. The company needed a way to optimize the map-based search ranking experience, one that surfaces the most relevant listings without hiding potential good alternatives or overwhelming users with visual clutter. Now that we've understood the business problem, let's shift gears and dive into the technical side. To see why the map-based search is so different, it helps to first recall how list-based search ranking works. In a traditional list-based ranking, user attention naturally decays as they scroll down. The top results get the most clicks, while items at the bottom are often ignored. Airbnb's ranking algorithm for list results uses this principle by sorting items based on their booking probability, which is the likelihood that a user viewing this listing will actually book it. The higher the booking probability, the higher the listing appears in the list. But on a map, listings aren't shown in a linear order. They are scattered as pins across a regime, with no bottom or top. There is no natural decay of attention by position, and user interactions vary a lot. So the strategy of a simple ranking by booking probability no longer applies here. To adopt this challenge, Airbnb needed to model how user distributes their attention spatially across a map, and then surface listings that not only have high booking probability, but are also likely to be seen and considered by the users. The team explored this problem through a series of iterative improvements, and let's take a look at how the iterative improvements look like. The first assumption the team tested was the simplest. It assumes that user attention is evenly distributed across all map pins. In other words, every pin has an equal chance of being noticed by the user. However, user attention is limited. Most guests only click a few pins before making a decision. So if there are too many pins, those few clicks might miss the best listing altogether. On the other end of the consideration, if too few pins are shown, users may feel restricted or miss their preferred choice. To test this trade-off, the team introduced a controlled parameter that limits the ratio between the highest and the lowest booking probability among the displayed pins. The tighter this ratio is, the higher the average booking probability of the listings shown on the map. When the team launched this experiment, which is to displaying fewer, higher quality pins, the results were pretty striking. Bookings increased by more than 1.7%, along with a noticeable improvement in quality bookings. This is measured by the share of trips that earned a 5-star reviews. At the Airbnb scale, this improvement is pretty massive, and the results showed that narrowing user attention to a more curated set of listings was a promising direction. Based on the success of the first assumption of user attention, the team explored a more nuanced model of displaying, which is the tiered user attention. They divided the map pin into 2 tiers. One is the primary pin, which representing the listings with higher booking probability, and they are displayed as regular oval pins with prices shown. Then it comes the secondary pins, or mini pins, for listings with lower booking probability, and they are displayed as smaller ovals without prices shown. By design, these mini pins drew far less attention, with about 8 times fewer clicks than the regular pins. But they still give users a sense of additional options. This structure prioritized attention toward listings more likely to be booked, while still keep less likely options accessible. This 2-tier map experience improved both the overall booking and the quality bookings by another 0.5%, confirming that guiding user attentions pays off. Finally, the team went one step further by modeling spatial attention, which is to understand how users interact with different parts on the map. They analyzed click-through rate across map coordinates to see where users tend to focus upon. Unsurprisingly, users clicked more often near the map's center and less around the edge or corners. With that insights, the team built a dynamic map recentering algorithm that adjusts the viewpoints to bring high probability listings closer to the center of the screen. This subtle but clever change made it easier for users to discover the best listings and reduced unnecessary map navigation. There is still a 0.3% booking rate improvement, and this represents another incremental win in optimizing how attention aligns with the booking likelihood. Across all these iterations, the team validated results through rigorous A/B testing, and tracking metrics like clicks to discovery and impressions to booking are also evaluated. The cumulative efforts of these improvements was a smarter and more intuitive map experience that helped both guests and the hosts. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Airbnb improved search ranking for their map interface. It is a challenge that sits at the intersection of user behavior, design, and data science. From assuming uniform attention to modeling tiered and spatial attention, the team systematically refined how users interact with map results. This work shows how aligning user attention with booking likelihood can drive real business impact. And it's a great example of how thoughtful modeling of user behavior can translate directly into product success. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.